So last time we covered super mesh analysis using dependent sources. So next topic is supernode analysis using dependent sources. So determine voltage Vx is the question. So this is the network. If you observe, there are three nodes V1, V2 and V3. So if you observe, there is a voltage source between node 1 and 2, right? So they form a supernode. So we cannot apply KVL directly to node 1 and node 2 separately. Okay, and this is the reference node. This is node V3, right? And there are dependent sources, right? This value is 2Vx. We have a dependent source of value 2Vx. So there should be Vx somewhere. So this is Vx. So whenever we have dependent sources, what we do? We write the dependent variable in terms of the other variables, which are V1, V2, V3, or in case of KVL, I1, I2, I3, right? So we write from network Vx. What will be Vx? This is plus, this is minus. So for voltage Vx or the node for voltage Vx, node 2 is at positive potential with respect to V3. So V2 minus V3, that is the potential difference. So this is equation number 1. Next, we say node 1 and 2 form a supernode, right? So therefore, what we write? V1 minus 6 minus V2. V1 minus 6 minus V2 equal to 0. Again, why this is minus? Because we are going from V1 to V2. So plus minus, we are going from plus to minus, so fall in potential. So therefore, V1 minus V2 equal to 6. This is the second equation, right? So three nodes, we should have three equations apart from the dependent variable. So two more equations are remaining. So next we write applying KCL to supernode. So what will we get? For supernode, what we do? We consider nodes 1 and 2 as one single node, right? So we assume currents are going away in all the branches connected with them, right? So what will we get? Let's start from here. So it will be V1, but here it is a current source and it is in the opposite direction. So minus 2 plus V1 plus 5 upon 4. So we are done with this part. Then this is V2 minus 2Vx upon 10 plus V2 minus V3 upon 11. Then this is also there, remember, plus V2 minus 8 minus V3. V2 minus 8 minus V3 upon 7 equal to 0, right? So we have one extra term here, Vx. So substitute Vx is what? V2 minus V3. So therefore minus V2 plus V1 plus 5 upon 4 plus Vx is what? V2 minus V3. So it will be V2 minus V2 plus V3. So it is only V3 upon 10 plus V2 minus V3 upon 11 plus V2 minus 8 minus V3 upon 7 equal to 0. So just substitute this. So first collect the terms in V1. So what is it? 4 inverse plus, that's it. So it is 0.25. So 0.25 V1, then V2 11 inverse plus 7 inverse. So I'll keep it fraction only to get the exact answer. Plus 18 by 77 V2. Then V3 is 10 inverse minus 11 inverse minus 7 inverse. So minus 103 by 770 V3. Constant term is minus 2 plus 5 by 4 minus 8 by 7. So when it comes this side, it will be plus. So 53 by 28. This is equation number 3. Right? So next, applying KCL to node 3. So again assume all are going away from the node. So let's take this first. So V3 minus V2 upon 11. This is directly a current of 12. So plus 12 plus V3 minus V2 minus 8 upon 7 equal to 0. So there is no Vx, so solve directly. So it is 0 V1, no V1 term. Then minus 7 inverse minus 11 inverse. So minus 18 by 77 V2, 7 inverse plus 11 inverse. That's it, plus 18 by 77. Yes, plus 12 minus 8 by 7. So 76 by 7 when it is on left hand side. So when it comes here, it will be minus 76 by 7. Right? So this is equation number 4. So we have got all the equations. So what do we write? Solving equations 2, 3 and 4. Therefore, what will we get? V1, V2, V3. So equation number 2, V1 minus V2 plus 0 V3. So 1 minus 1, 0, 6. In equation number 3, 0.25, 18 divided by 77 minus 103 by 770 equal to 53 by 28. Then equation number 4, 0 minus 18 divided by 77, 18 divided by 77 minus 76 divided by 7. Yes. So we'll get V1 as, so we'll write the exact value now, minus 10.6281 volts. V2 is minus 16.6281 volts. V3 is minus 63.0726 volts. But what is the question? Determine voltage Vx. So Vx is what? V2 minus V3. Therefore, Vx equal to V2 minus V3. Therefore, Vx equal to, Vx is V2 minus V3. So minus 16.6281 minus of minus 63.0726. So 46.4445 volts. So this is our final answer, right? So this is the way you have to solve. So let's take one last sum. Find the node voltages in the network shown. So which are the node voltages? They are already given, V1, V2, V3, V4, right? And this is the ground node. So it is already given as ground node, right? So if you observe, there are 4 nodes apart from the ground node. So we should have 4 equations. So if you observe node 1, it is directly connected to ground through a voltage source of 12. So if you apply KVL here, V1 plus 12 minus 0 equal to 0. So what you can say directly from the network, V1 plus 12 minus 0 equal to 0. Therefore V1 equal to minus 12 volts. So this is our first equation. We get it directly. I forgot to write the dependent variables, so I'll write it here. So there are Vx and Vy. So somewhere we should have Vx and Vy. So what is Vx? This is plus, this is minus, so V2 minus V1. So Vx equal to V2 minus V1. Equation number 2. Strictly speaking, you should write this first. And Vy is what? V4 minus V1. Right? In applying KCL to node 2, can I apply KCL there? Yes, I can apply. So apply KCL at node 2. So second sum, I will not write everything. So again assume all going away. So V2 minus V1 upon resistance value is, this is 0.5 ohms. So upon 0.5, now this current is going downwards and we have a current source which is pointed upwards. So we'll write what? Minus 14 plus V2 minus V3 upon 2 equal to 0. So collect the terms in V1. There is a single term, so this will be what? Minus 2V1 plus 2V2 plus 0.5. So plus 2.5 V2 minus 0.5 V3 equal to 14. No need of calculation. So equation number 4. Right? Then what we'll do? Apply KCL at node 3. But if you observe between node 3 and 4, there is a voltage source. Even though dependent voltage source, so it will form what? A supernode. So node 3 and 4 form what? A supernode. Right? So therefore, V3 minus 0.2 Vy minus V4 equal to 0. And what is Vy? V4 minus V1. So therefore, V3 minus 0.2 times V4 minus V1 minus V4 equal to 0. So therefore, V3 minus 0.2 V4 plus 0.2 V1 minus V4 equal to 0. So solve this. So therefore, 0.2 V1 plus V3 minus 1.2 V4 equal to 0. This is equation number 5. Right? Then applying KCL to supernode. So what we do again? Consider this as a single node and currents going away from this node. So let's start from here. So V4 minus V1. I forgot this resistor also. Let me check. So this is 2.5 ohms upon 2.5 plus V4 minus 0 upon 1. So V4 upon 1. Then we are done with this side. So come here. So V3, this is a current source. So what will it be? Minus 0.5 Vx. Why minus? Because it is both are in opposite directions. Plus V3 minus V2 upon 2 equal to 0. Therefore, so here we have Vx. So Vx is what? V2 minus V1. So therefore, V4 minus V1 upon 2.5 plus V4 minus 0.5 times V2 minus V1 plus V3 minus V2 upon 2 equal to 0. So therefore, V1, this is what? 0.5 V1. So 0.5 minus 2.5 inverse. So it is 0.1 V1. Then minus 0.5 V2 minus 0.5. So minus V2. Then V3 is only one term. So plus 0.5 V3. Then V4 is 2.5 inverse. Plus 1. That's it. So 1.4. So 1.4 V4. And constant term, there is no constant term. So equal to 0, equation number 6. So what will we do next? Solving equations 1, 4, 5 and 6. So we are getting 4 equations. So we cannot solve in calculus. But we know that V1 is minus 12. So substitute minus 12 in all the equations. So what will happen? So I will not solve this. This is your homework. Substitute minus 12 here. So we'll get one equation. Right? Let's say it is equation number what? 7. So you have equation number 7 in terms of V2 and V3. Right? Then substitute V1 here. So you will have V2, V3, V4. Let's say it is equation 8. So 7, 8 and finally here substitute V1. So you will have other equation 9. Then what do you do? Solve 8, 9, 7 also. 7, 8 and 9 simultaneously. So we will get V2 equal to, V3 equal to, V4 equal to. Right? So solve this, you will get the answer. What is the unit? Volts for everything. So what do we have to find? Find the node voltages in all the networks shown. We have already found out V1. So similarly, we find out V2, V3, V4. Okay. So make sure you solve this. As I told, there will be assignment coming after we finish the module. Thank you.